from FDM and TDM. Now we discuss SSB. SSB modulation. DSB modulation is used, but SSB have advantage over DSB. What is advantage? If AM we are transmitting this type of pattern, center at omega c, bandwidth is omega m minus and plus omega c. Bandwidth is twice omega m. In DSB, both the sideband without carrier. In AM with carrier. In DSB SC or DSB, both the sideband upper and lower. Upper DSB, USB and LSB, both the sideband still maintain. Each sideband contains the complete useful information. In DSB, both the sideband have complete information. Complete information, but carrier is absent in DSB-SC. In SSB, one of the sideband is suppressed, either this or this. Either we suppress LSB or USB. Either of the sideband can be suppressed through a filter, through any other idea. If we suppress, what is the benefit? In this case, bandwidth is twice omega m. In SSB, either of SSB, bandwidth is omega m. We are saving bandwidth. For AM, our complete expression is, in short, carrier upper and lower sidebands. If we transmit in totality, total 50 watt power, some with modulation index is 1 upon root 2. Power in carrier is 40, 5 and 5 watt. In DSB-SC, carrier is absent, complete power is useful power, but it is double, 5 and 5, 10 watt. In SSB, either U or L, either of the sideband, we are transmitting only 5 volt. So reducing power by large extent from 50 to 5 and bandwidth by half. Both benefit attach with SSB, USB or LSB. Now I write expression for SSB. What is the exact expression for SSB is? SSB X SSB, complete expression for SSB is M1 or MT cos omega CT minus plus MH sin omega CT. This is the complete expression for SSB, where minus sign used for USB, plus sign used for LSB. MH is new term added in the system. MH is Hilbert transform of message signal. Hilbert transform of message signal. How can we use this Hilbert transform? What is Hilbert transform? MT pass through a block, I told them, is Hilbert transform. Output is Hilbert of that message. Expression for Hilbert transform is, because Hilbert transform I denote by HT, time domain expression is 1 upon pi t. 1 upon pi t Fourier transform we discuss in signal and system, minus j signum omega. MH x tau h 1 upon pi t minus tau d tau from minus infinite to infinite. This is the expression for Hilbert transform. Here we took mh is input, then we have to take m also. Here use instead of x m is our input, and input is in this way, then we get result is Hilbert of this. In frequency domain we get direct result because here we have to convolute mt convolution st. In frequency domain we can multiply Fourier transform of these two. Or for magnitude and phase spectra, this magnitude spectra of 1 upon pi t minus j sigma, magnitude spectra is 1, phase spectra is minus 90 degree. Magnitude spectra come from a real portion is 0 and imaginary portion is 1. Root of this is 1 and angle is tan inverse is minus 90 degree. Means Hilbert transform provide no amplitude change to a signal, provide only minus 90 degree phase shift. Provide minus 90 degree phase shift. If someone apply cos omega naught t to a Hilbert transform 1 upon pi t, what will be the result? इसका result क्या होगा? Cos is differ by minus 90 degree. If we apply sine over here, what will be the result? If cos is differ by minus 90 degree, exact result is, if we apply same, sine will also be differ by 90 degree. Cos 90 degree difference means in this quadrant. Originally in this quadrant 90 degree difference is in this quadrant 90. In this quadrant, what is the value of cos or sine? How can we detect? We can detect from waveform also. This is the cos waveform. I want to delay this waveform by 90 degree. If I delay it by 90 degree means I am here. If 0 is previously there, I delay it by 90 degree means it is now converted into sine omega. Cos in this quadrant is positive, so sine omega naught t. If I delay sine by 90 degrees, sine in this quadrant is negative, so result is minus cos omega naught t. We can draw also with this waveform also. If waveform is sine, 0 is shifted to this. We again want to delay by 90 degree. I am here. Starting at 0 location, I am here. In this condition, negative means cos maximum. At 0 location, maximum negative value means minus of cos is our answer. Hilbert transform provide minus 90 degree phase shift. If we add these two terms and apply it to a Hilbert transform, what will be the result? Result is accumulation of these two. Accumulation of these two. Accumulation of these two means if we apply individual input, result will be individual output addition. Means it following superposition means it is a linear system. It is GATE 2006 question. Hilbert transform is a linear, non-linear, causal and non-causal. It is a linear system. This idea of Hilbert transform applied to SSB. So now again I write expression for SSB. Now I took M1T is a one single tone component AM cos omega MT. Then SSB USB is at this point I put this value into this and Hilbert transform MH Hilbert transform at this location and result will be right here. I write down expression. This expression is now reduced by formula cos A cos B minus sin A sin B cos omega C plus omega MT. This expression for XSSB USB. In same manner XSSB LSB USB. In same manner we write expression for LSB is cos omega C minus omega MT. LSB. The SSB, LSB and USB both can be write in term of expression for single tone. Now we will discuss generation idea of SSB. There are two methods to generate SSBs: frequency discrimination or frequency discrimination method or filter method. Filter method. Second one is phase discrimination method, means phase shift method. Phase shift method. I discuss both one by one. First I discuss the spectral diagram of SSB is an AM. If AM is generated, then diagram is omega C. SSB can be generated from spectrum of AM. In this spectrum we showed USB, LSB, USB and LSB with carrier component. We want to suppress carrier as well as one of the sideband. If we suppress lower sideband, only retain USB, means generated SSB is SSB USB with the help of high pass filter. This is known as SSB generated through filtering method or filter method. We use appropriate value filter, so in this way we generate SSB USB. In second idea we generate LSB is retained. SSB LSB means we use filter here is low pass filter of omega C. SSB can be generated through filter method. Filter method ideal, we are using here ideal filter. Ideal filter is not realizable, practically realizable, because which is all ideal filter are non-causal, or non-causal component are can't be physically realizable, so we can't realize filter through this. But filter method is very economical method or broadly used for the reason because SSB is suitable for, because filter method is very economical, so SSB is suitable for a transmission of voice or telephony purpose, very suitable for telephony purpose. Reason behind that, because voice band is in this range and we use filter up to 5 kHz for SSB generation. Voice signal original band is lump sum 300 to 3400. Same in negative side, exact replica in negative side. bandwidth considered from only positive side. If we use filter method, filter is not ideal, it is practical. Some initial spectral gap is there where filter suppress the initial component of the message, also in negative initial component of the message, but we have no important initial component in 0 to 300, so uh, practically does not affect on practically this transition from 0 to 300 does not affect on quality of voice, so it is best suitable method for voice transmission. But in audio range, actual audio range is 200 to 20 kilohertz. Initial spectral gap, no initial spectral gap, very negligible initial spectral, there is 10% spectral gap, there is 0.01% spectral gap, so filter method is not useful for this audio range, audio baseband signal. In video also, no spectral gap from 0 to 4.5 megahertz, no spectral gaps, so video is not useful for us. For video, ssb is not useful, so ssb is useful. Ssb generation via filter method is useful for only voice signal telephony case. In remaining case, ssb is not useful via filter method. Reason behind that, no initial spectral gap, and best filter method used in ssb is via mechanical filter, which is not bulky, small in size, largely used for generation of ssb via filter method. Second method is phase shift method. Phase shift method, in this method we just changing the phase, in this method we just changing the phase via phase shifter or using Hilbert transform block. The block diagram of this is, block diagram we can construct in this way. From expression to block and block to expression transition is very smooth. Mt cos omega ct, Mt multiply with cos omega ct with the block of DSBSC. In next step we require MHT. MHT come from Hilbert transform of this. Now we want to multiply sin omega ct. Sin omega ct come from minus pi by 2 phase shift. If minus pi by 2 phase shift, we got sin omega ct. Here we get multiplication in these two terms, and addition and subtraction come from summer, and at the end of the we got result ssb. Upper sideband and lower sideband depend on sign used. If negative sign used, it is USB. If positive sign used, it is LSB. In phase shift method, ease of switching from one sideband to second sideband transition is very easy as compared to filter method. Drawback is very accurate phase shifter is required. If small change in phase, it produce very large change in SSB generation. Very large amount of SSB generate large amount of error in SSB generation. Drawback is very complex hardware for Hilbert transform. Accurate and complex hardware is required. Demodulation of SSB SC. Demodulation purpose we can use ED, envelope detector. If we use ED for demodulation purpose, XSSB MT cos omega ct minus plus mh sin omega ct. If we apply ED, what is the rule of ED? Whatever multiply with cos root of this means m square t plus mh square t. This if both term present in SSB or already present in transmission, if we apply, result is maximum value, peak value. It comes from root of this. If either of term is present, single term, then we can apply ED for demodulation of SSB. If both term are present, result will be this. Instead of getting MT or MST, we get combination of these two, which was not desirable result, which was not original message signal deviation. Means ED is not applicable in case of SSB. If either of term is missing, it is useful for demodulation purpose. Otherwise, we use synchronous idea to detect demodulate SSB. How can we apply synchronous idea? As in DSB, same method. Balance modulator and product modulator, either of term we can use A cos omega CT LPF AMT by 2. If I use instead of A cos omega CT 2 cos omega CT, result will be MT only. SSB term applied here. We apply SSB term here with cos omega CT multiply. Expand this term by multiplying. Solve this term. Twice omega CT. Both terms are eliminated by low pass filter. Last result is AM by 2 MT. If we use, instead of using this term, we use this, result will be MT. No scaling factor. If any phase deviation locally generated carrier have any phase deviation, result is, what is the effect on demodulation? We can calculate. Instead of 2 cos omega CT, we use 2 cos omega CT plus 5. This 5 is carry forward up to this location, and at end of the result, if phase deviation exists, our output is AM by 2 MT cos phi A by 2 MT sin phi. If phi is 90 degree, what will be the result? Cos 90 is 0. Our result is, sorry, MH. Our result is MS half MH. If cos phi is 0, our result is half phi equals to 0 degree A by 2. Phi equals to 90 degree is, result is MT. A by 2 MT, A by 2 MHT. In both case we got the result. Means there is no quadrature null effect. In DSB there is quadrature null effect. In SSB there is no quadrature null effect. Now I move to a question related to SSB. Question is, in 2006 gate paper, if a spectral component, message signal spectral component MF is given to us, MT is applied to a block, result will be YT. We want to calculate YF, spectrum of F output. This block is related to SSB LSB, because Hilbert is here. We just minus 90 degree from this carrier means same block of SSB. Plus sign here means SSB LSB. First we identify this block is related to SSB LSB. Means we have to develop first DSB. In the message signal, bandwidth is given to us B and minus B, means total band limited up to B. If we develop DSB, Then I will mark in this way omega c minus plus b minus omega c minus omega. I mark everything. Now in case of DSB, this is the pattern. Either of the one component is suppressed. We want to generate LSB, means USB is suppressed. USB is suppressed, result will be USB is suppressed, result will be this. Back to the diagram. In this diagram, carrier frequency is in hertz, FC is 2 pi V 2 pi FC. FC is B only. By replacing omega C with B, this component is converted into omega C with B half B minus B is 0. B minus omega C with B minus B is 0. Again same point, minus B means that is our result. It is a result at output which spectrum is shown in this way. Now we will discuss new topic, multiplexing. There are two type of multiplexing, analog and digital. In analog category, FDM, frequency division multiplexing. In digital category, time division multiplexing. What is multiplexing? Multiplexing is management of resource. Resource may be frequency, resource may be time, resource may be space, SDM. Resource may be angle, ADM. Resource may be code. Any of the resource we are managing for the purpose of number of source means called multiplexing. Multiplexing used for different purpose. Basic multiplexing is management of the resource. If resource is frequency, analog type of multiplexing, FDM, frequency division multiplexing. If resource is time, time division multiplexing. Space, angle and wavelength, WDM, wavelength division multiplexing. DWDM, dense wavelength division multiplexing, and lot more. In frequency division multiplexing, we have a channel. In the complete channel, we assigned a bandwidth to message 1, message 2, message 3, and message 4, and so on. This assignment is called frequency division multiplexing. We assigned a particular frequency band to message 1, 2, 3, and 4. In time division multiplexing, we have limited time. Time slot 1 is allotted to message 1, time slot 2 is allotted to message 2, 3 is allotted to message 3 and 4, and repeat. This procedure is repeat. It is called time division multiplexing. In frequency division multiplexing, we are dividing available channel bandwidth into different available source message. In this way, they can't interfere with each other, and at receiver end we can easily demodulate. So for example, in a school we are managing classroom, or in a college we are managing classroom from first year to final year. For first year we can arrange in many way. First, a building has 4 floors. First year on first floor, second year on second floor, third year on third floor, and final year on fourth floor. This is the one idea to manage a classroom. Second idea to manage a classroom, a particular classroom for first year for the time slot of 8 to 9, or second time slot second one, third time slot third, and on the basis of time slot we can shift the classroom and many more ideas. This in this way we are managing the building as per classroom and student availability and student strength and its timing and everything. We are considering all the parameters. So multiplexing is management of all the points. We are managing all the points. Now we discuss frequency division multiplexing. For frequency division multiplexing, signal should be band limited. What is the definition of band limited signal? Band of the signal should be 0 for frequency above omega m, otherwise some value, maybe 1, maybe omega, maybe some sine value, some cos value, to eliminate insignificant higher frequency to band limited signal up to desired frequency component. So we have to band limit this function via a low pass filter or band pass filter. In this case we are using low pass filter. We discuss the block diagram of FDM. We consider the three band limited message signal pass through LPF to make it band limited and modulate and drop on the channel. In the recollection process, pass through BPF with appropriate center frequency FC1, FC2, FC3, and use appropriate demodulation. If we use AM here, envelope detector for demodulation, and recollect the original message signal. If we use this type of pattern for M1 spectrum pattern, for M2 and for M3, at the result we get same type of pattern here. And composite diagram can be constructed in this way. Composite diagram can be constructed in this way. In complete channel bandwidth is occupied by three message signal, which is our example. If first signal is centered at omega c1, second is third is in this way, in the channel they travel in this way. Between the message signal there is some spectral bandwidth gap. This is known as guard band. This is known as guard band. Guard band used to avoid adjacent channel adjacent signal interference due to adjacent signal. This avoid the, if guard band is zero, it might be some interference due to adjacent signal. Practically some guard band is used. Practically guard band is used, it is not zero, because ideal low pass filter have sharp cutoff frequency, but ideal low pass filter is can't physically realizable. So practical low pass filter have some adjacent frequency may be enter into this. Now we discuss about bandwidth of the channel. Bandwidth of the channel may be in this way. The range of frequency that is capable of transmitting without any distortion is channel bandwidth. If we consider the channel bandwidth is 200 kilohertz and each channel occupy 10 kilohertz, after modulation is 20 kilohertz, number of channel can be accommodated in this bandwidth is, it is 10 channel if no guard band is used. It means in order to multiplex more number of signal bandwidth, in a channel, the channel should be as high as possible and bandwidth of the signal is as low as possible. Bandwidth of the signal is as low as possible, signal, and bandwidth of the channel should be as high as possible to increase number of message signal in a channel. For example, in a twisted pair, in a twisted pair, channel bandwidth is 500 kilohertz. In coaxial cable, channel bandwidth is 500 megahertz. If telephone channel we want to accommodate in twisted pair, telephone channel has bandwidth is 4K through SSB. If we want to accommodate telephone channel without guard band, we can directly accommodate telephone channel in 125 channel can be accommodated. If some guard band may be used of 1 kilohertz, we can accommodate 100 channel of voice signal of telephony. If our basic signal is video signal megahertz, we want to accommodate in twisted pair line. It is not possible because video channel has larger bandwidth than twisted pair. So we have to use coaxial cable, and coaxial cable can be accommodate 100 TV channel in it. That's why coaxial cable is more suitable for TV transmission and twisted pair is suitable for telephony purpose. I took one example. 10 signal, each band limited, each band limited to 5 kilohertz are transmitted through a channel after modulating FDM. The after modulating using FDM, guard band is used 2 kilohertz. Determine the bandwidth of multiplex channel. Bandwidth of multiplex channel. Multiplex channel. 10 signal, each is 5 kilohertz. FDM is used. Guard band is this much. Question 1. If all modulator is AM. Question B. If all modulator is SSB. Question C. First four is AM, next two is SSB, and last four is DSBSC. Then calculate bandwidth. If all are AM, means all are arranged and modulate with AM and transmitted with this much of guard band, means all are AM, means all are accommodated in this pattern, and so on, means AM bandwidth is twice of message signal bandwidth is 10K. Solution for A. 10K. 10K for one message signal. 10K into 10. Total 10 message signal plus in between guard band is number of message signal minus 1. 10 minus 1 into 2 guard band. Formula is n into bandwidth of message and n minus 1 into guard band is total bandwidth. 100 plus 18 is 118. B question. If all are SSB, then bandwidth for this is 10 into 5 because SSB bandwidth is only omega m, not twice, and guard band still occupies same space 9 is now 68 answer. Question number 3rd. Bandwidth if first 4 is AM, first message signal bandwidth is 10. If first 4 is AM or AM, because for AM is twice omega m. For DSBSC is twice omega m, and for SSB is omega m. Twice omega m is 2 into 5 is 10. For DSBSC 2 into 5 is 10, 10k, and for SSB is 5 into 1 is 5k. First 4 is DSBSC, next 2 is SSB, and last 4 is DSB, and guard when still maintained. We can calculate 10, 80, 90 and 18. 108 kilohertz is minimum channel